Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which extracts leaves of a binary tree in a doubly linked list. First, let us take an example. In this example, the nodes 7, 8, 5, 9 and 10 are leaf nodes and we form a doubly linked list of them. Now, let us see the algorithm which will assist us in extracting leaves of a binary tree in a doubly linked list. Let us also have a sample tree to test our algorithm. We pass the root node which is 1 and head ref pointer which we initially set to null. As root is not null, we check leaf node. Since 1 is not a leaf node, we recursively call for the right and left subtrees using a call stack. So first, we pass the right child of 1 which is 3. Hence, root will point to 3. Again, as root is not null and 3 is not a leaf node, we pass the right child of 3 which is 6. Hence, root will point to 6. As 6 is not null, we check if 6 is a leaf node. Since 6 does not have any child, it is a leaf node and hence we set root's right point to head ref. As head ref is pointing to null, we make head ref point to root. So it will point to 6. Next, we return null. Hence, 3's right will point to null. We resume execution for node 3 and now pass the left child of 3 which is null. So root will point to null. As root is pointing to null, we return null. Hence 3's left will point to null. Finally, we return root and hence 1's right will point to 3 and execution for node 3 will be over. Execution for root 1 is resumed and now we pass the left child of 1 which is 2. Hence root will point to 2. As root is not null, we check if 2 is a leaf node. As it is not, we pass the right child of 2 which is 5. Hence root points to 5. We check if 5 is a leaf node. Since 5 does not have any child, it is a leaf node and hence we set 5's right to head ref. So 5's right will point to 6. As head ref pointer is not null, we set head ref's left point to root. So 6 left will point to 5. We make head ref point to root. Hence, head ref will point to 5. Finally, we return null. Hence, 2's right will point to null. We resume execution for node 2 and now pass the left child of 2 which is 4. As root is not null but 4 is a leaf node, we make 4's right point to 5. As head ref is not null, we make head ref's left point to root. Hence, 5's left will point to 4. Next, we make head ref equal to root. Finally, we return null to 2's left. Next, we return root to 1's left. Hence, 1's left will point to 2. We have the final doubly linked list. With this, we finish execution of this program. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.